Yep, go ahead.
Yeah.
Sorry.
Yeah, so the architecture of LNP Node, we are trying to cover it now. Sorry, we delayed the video recording. I was talking about that the node is consisting of microservices, each of which is running as a separate thread or a separate process, and it solves a single task. So we have a microservice per each remote peer. We have a microservice per each channel, and they can communicate in many-to-many modes. So basically, you can have a channel that links multiple peers, and this will allow to have a multi-peer channels in the future when the Lightning Network will be developed. Well, then we will have channel factories and other types of functionality. The architecture of these microservices talking to each other will allow to add that natively without any changes in the code base. Additionally to that, we have a microservices for routing, for gossiping, a microservice called LNPD, which is responsible for spawning a new threads per each newly created channel. And a microservices displayed here in red, which do perform a specific business logic related to some module of the channel operations. Because with the channel operations, we have blocks like creating HTLC, HTLC-based parts of the transaction and managing HTLC-based payments. And this module can be replaced with other modules like PTLC page or elliptic point. So it's very well defined functionality. There could be a module for penalty mechanism and a module for L2, so they can be interchangeable. And of course, there will be a separate microservices adding such functionality as RGB or DLC. And these microservices, they are organized in a conveyor way, meaning that when the channel, any of these channel microservices needs to update the state of the channel, generating a new tree of the state of the channel transactions, it sends a request. I will talk a bit more about how all these many-to-many services are communicating with each other, but it basically sends a request to a message bus. So each of those services modifies and the transaction structure. These transactions are supplied by the channel daemon in the form of partially signed Bitcoin transactions. And each of the services are able to modify the structure of them, adding outputs, tweaking public keys, or doing other parts, adding additional transactions. And they're working as a conveyor. So at the end of the day, the channel service doesn't know anything about specific type of the channel it operates with. The only thing it knows is that which of the modules or business logic it needs to call and in which order in order them to construct the proper channel transaction tree. And by this, you basically change the way the channel works by changing the configuration. So you can again replace HTLC with PTLC or add RGB just by a single configuration argument or inside the configuration file. Or different channels may operate different versions of Lightning Network or different versions of like having RGB or not having RGB. And these business logic modules, which are shown in red, we have one instance of this logic. So they are not specific to a channel. They serve many channels at the same time. And at the end of the day, the node itself is a swarm of these multiple threads or daemon communicating with each other, which may be distributed across different devices, instances, services, Docker containers, or assembled within a single binary or an application, like within the mobile wallet. And all of this crazy daemon stuff, because I know that all developers, they hate multi-threading and all this system message buses and all that kind of very complex stuff. This complexity is hidden behind the architecture of the node itself. And I will be briefly showing how it works. The core concept is that we use two main things to make this simpler. The first one is this stack of Internet 2 protocols I was talking on the previous call. And again, I ask everybody who is interested in that to watch that talk. Actually, it was audio recording to listen to it. Olga probably will post the link. And the Internet 2 allows us to build communications between nodes and microservices in a way that we are not restricted by the DNS, by IP addresses, by SSL certificates. We don't need basically them. We can operate with that over to where we use public keys as identifiers of the microservices. And we utilize existing stack of Lightning Network protocols to build communications even outside of the Lightning Network. So we use this stack of Internet 2 things inside the node itself, and all the daemons communicate with each other through that stack. And this stack is implemented as a part of LNPBP core library with a layerization of these protocols. I will actually show the way it looks. So here we have this Internet 2 protocol stack with a basic layer composed of TCP/IP, on top of which we can use a Tor, which is basically SOCKS 5 proxy for transport, and we use special transport framing protocol, the layer that is absent in normal TCP/IP stack. And this transport framing protocol normally in Lightning Network, Lightning Network use just a pure TCP, but we extended it such that it supports transporting, layering over existing protocols like HTTP, WebSockets, SMTP, and zero message transport protocol that allows us to bypass firewalls, proxies. So if you, for instance, have only HTTP communications available, you can still flow your Lightning Network traffic through HTTP. And on top of that, we have a session layer, which replaces the OpenSSL and TLS encryption with a noise-based encryption protocols, like Lightning Network Noise Protocol or other protocols. Today in the demo, I will be using version without encryption. It's an encrypted box, so I can show you the actual communications happening between the parts of the node with Wireshark, because otherwise you will just see a random noise traveling in the network. On top of that, there is a presentation layer, Lightning Message Protocol, which is basically Bolt 1 and Bolt 8, some parts of the Bolt 1 and Bolt 8. It defines the structure of the Lightning message and how it is framed and forwarded into encryption layer below. And on top of that, we have an application level protocols where the actual existing implementation of the Lightning Network, it uses this box, which I called, because I can't call everything Lightning Network. I need to invent some names, so I will put it Lightning Network Peer Via Protocol. And this Peer Via Protocol is basically what we have in Bolt 2 as definition of the Lightning, of the messages that are supported by Lightning nodes and that have special meanings. So this is an application level protocol. Next to that, we developed another protocol, which is a form of RPC protocol. And this protocol is used for communications between the microservices in Lightning Network node. I would like to ask everybody to ask the questions, just interrupt me, because we have many participants on the call, and if you have a question, just start talking and I will be answering. I was presenting that on the last call, so I wouldn't be going into all the details of this Internet 2 stack. I'm just giving a context for better understanding of the node functionality. The next thing that I would like to, also I would like to show how it looks in the code. So if we will go I'll just change the screen a second. We will go to the LNPBP library. So this is LNPBP core library, which is actually implements all the business logic for Lightning Network, for RGB, and for some Bitcoin protocol extensions. So this library is consisting of main module. Here we have Bitcoin protocol extensions related to deterministic Bitcoin commitments, single-use seals based on Bitcoin, and some extension to script types. We have LNP, which is Lightning Network protocol. And this layerization that I just showed on the slide, where we have a transport about that session level, about that presentation level, and about that application level, it is reflected in the structure of the modules. So we have for transport, we can use TCP, WebSockets, zero message queue. For session, we can go with a special transcoders, like implementing noise or no encryption here. On the presentation level, we extract the special unmarshallers, the data types out of the unencrypted data and present them as a Lightning Network messages. And above that, we have an application level, which actually implements such things as actual Lightning Network messages. Here you see the last of them, init, error, and so on. And the other way of using it is to use them in RPC connection. So we have an RPC specific implementation here as well. And when you are going to develop a part of the node or some other types of the nodes, because this stack of protocols can be used arbitrarily in any software, enterprise level software, client server software, we have a special module called services, which implements the main patterns composed of these LNP protocol layers. And these patterns are client server. For instance, you can have RPC ZMQ server, which will run out of the box with all complexity in there. You can use it for a client communications. You can use it, I will be showing how we use that for enterprise service bus. So basically we have enterprise service bus controller which runs inside each of these microservices. This is a networking part and the Lightning Network part. Also, we have an RGB, of course. We have a set of paradigms like client-side validation, single-use seals, which implements the main API in a very safe and secure way. And we also have separate standards implementing different parts of LNPBP technology stack. So this is the core library, and this is an overview of the networking. And before we go to demo, the last thing I would like to mention are these message buses. So you're probably familiar with this concept of enterprise service bus, where multiple services connect to each other. It's quite a centralized architecture. And these services have to be aware about the contract conditions of the API. And it is usually used in large enterprise setup and environment like banks and very large international companies. However, what we try to do is we try to bring this internet to a protocol stack with this censorship resistance and end-to-end encryption into the decentralized world together with the redefined understanding of enterprise service bus. So these all microservices, they are not just talk to each other, and they are quite decentralized internally between themselves, but they connect to each other using so-called message buses. With LNP Node, we have 3 message buses. One of them is control bus, is used for control requests sent between them. Like if you need to order another daemon do some job, you use this control bus. The second bus is a message bus, which is a messenger bus here. And basically, it allows to transfer the Lightning Network messages coming from the Lightning Network itself. So each of the connection daemons, they are connecting to the remote peers, and everything they receive from the remote peers, they publish into this message bus. And other services, they subscribe to particular types of the messages. And when these messages arrive, they're going into that bus, and these specific services, they are notified only about a very specific set of messages which are of their interest. So routing messages are going, and gossip messages are going to gossip and routing microservices. Messages specific to a particular channel are going to the daemon managing that specific channel, and so on. And the third bus is actually the bus used by channel daemon and modules implementing different parts of Lightning Network functionality. It's shown in red here, extension bus. And this bus is used for the construction of the channel transaction structure, as I was describing before. And all of these buses are implemented in case of LNP Node and other nodes we are doing using zero message queue. It's a very advanced technology that helps to abstract from the complexity of multi-thread processing. So basically, each of the daemons, except only one, a connection daemon, which is caused by some complexity with the TCP management, but each of these daemons is a single thread. But when you need to have a multi-thread processing, you basically increase the number of these daemons. And all communication is managed behind the curtain with this zero message queue runtime. So these are technologies that we put together to build such a thing as a Lightning Node. And oh, sorry, I again forgot to switch the monitor. And here is the slide I was talking about. And with this, I think I can start moving towards the demo. The final slide before that, it shows how these services constituting LNP Node are connected with each other. So there is Lightning Network peer in the Lightning Network connected through the TCP socket here, and we have a reading and writer part which work in asynchronous mode, so we can read and write at the same time and do a non-blocking things. That's why connection daemon actually have two threads. So this black box is one thread and the rest is the other thread. And there are other daemons which are talking to each other through this zero message queue, managing their own very specific set of functionality and state information. Okay, so switching to the demo, how it all works in the code and the real life. So LNP Node, it consists of the binaries. We have one binary per module. The HTLC and other parts, they are not finalized yet. They are still in the development, under the development, but we already have a connection daemon, channel daemon, gossip daemon, routing daemon, and a core managing daemon. Plus LNP CLI is the command line interface I will be using to demonstrate some of the functionality today. And the most important that what this command line interface does is it just sends a control messages to the same message bus as I was showing you before. And when you will be integrating the Lightning Node into a wallet or into an exchange, what you will be doing, you will be actually also only sending a control messages to this message bus and get replies on them. To simplify this further, we even provide an integration module. Right now we have it on Rust plus different language bindings, but in the future we plan to have native language interfaces to this message bus, which will allow you to very simply integrate into the node infrastructure. Each of these daemons have their own directory, where you have options for the daemon, the runtime of the daemon itself. And within the runtime, you see for each message bus, we have a special handler function that receives the requests it classifies requests, and depending on the request, it performs some actions. Like here, if we receive a control request ordering us create a channel, we issue a Lightning Network accept channel message to the specific peer and send it over other message bus. So this is how the business logic is constructed. You basically react on different events and issue new commands to different modules basing on those events. So here, another example of how it is done. Like when we get ping response, I will be showing how it works in practice. When you're getting ping response, we are doing pong. So, and that's how the whole Lightning node is developed. You basically, inside each daemon, you define the messages you're interested in, and you create a handlers for those messages performing some actions. So basically that's all, because the core definition of all the networking of all system message buses, it was part of the core library, which I just showed. And here in Lightning Node itself, you have just connections of different modules with each other without any advanced business logic. So let's go to the demo. Here we are. I will be using Unix machine, but Linux machine, but the same demo can be shown on the Mac OS. I haven't tried on the Windows, the current version, but we were able to build RGB Node for Windows, so I think we wouldn't have a big problems with running this thing in the Windows machine as well. So we, just to show from the very beginning, I will go up and download everything from the very start. We will just use git clone. The repository of the node is LNP Node. Then we're going into this directory and issue a cargo build cargo install command. We need to specify a path, current path, otherwise it doesn't work. And we need to specify that we are building all binaries and all features for all those binaries. So it will create a task building all the stuff. And while it happens, I will, yeah, it's quite fast, more or less. You also need to install some dependencies before making a build, in particular zero message queue library. These parts are described in the README of the LNP node. I will try to show it to you. Here. Here in the instruction. And we have some of the slides and explanations on the architecture right inside the README. Oh, sorry, it's not here anymore. It was before. But basically, if you look into the Rust LNPBP library, there are build instructions here. Yeah, these are dependencies, basically what you have to install before doing the compilation. In the parallel, I will show the same thing on my own machine. So I have already created a commands which allow me to start different parts of the daemons. In general, at the end of the day, the whole node will be launching with a single command which will spawn all the necessary daemons. But for debugging options, I have created a set of commands which allows me to start a connection daemon in a listening mode. That's where we usually start everything that we do. So we tell to the daemon to listen on the current IP address. We can specify details about the IP address here if you'd like to. And what it does, it listens for incoming connections. It tells you about its public identifier. So use this public identifier as your public IP address. You can tell it to other parties, and they will be able to connect to this connection daemon. And I have a local demonstration of how I can connect it from the same machine. And for that, I'm saying to connect to the node that I'm running on my local address. So I issue the connection daemon with a connect command. And let me show how this works. So now in the listen part, we see that it have acquired the new incoming connection from the same host, but from a different port. And it established, it basically forked a new instance of the connection daemon. So if we will look into the processes that we are running, here I have put a connection. We see 3 connections daemons running in the same time. I don't know, it's some specific system process on macOS, running in the same time. One is in listening mode, so it accepts new connections. The second one is the one connecting to the first one, and the third one is the one spawned for this specific connection coming from the second one. And these nodes start to interplay with each other because they're connecting, they're sending ping and receiving Pong responses on their pings, exchanging random data. So we see both of them sending data to each other. I hope we are ready here. Yes. So I will start connection daemon in listening mode. It's a shorthand for listen. I can write listen. It is the same as just L. And for V letters shows that we will print all the possible verbose information. So we can do a 1 and we will have very brief reporting. And with 4, we got complete trace of everything that is happening. So again, we started a daemon in the listening mode, and we connect to the daemon above with each key on here. Oh, I stopped it. Here we are. And they are now connected. Each 30 seconds, if nothing else happens, they will be sending ping requests to each other, exchanging these pings because we haven't told them to do anything else. And what we also can do, we can emulate this behavior by using LNP clear command, by sending a ping command from here. And just it should start happening. Yeah, you see they exchange pings between themselves. And if we will go to Wireshark, we will be able to see the network traffic happening between them. Next, I would like to show the channel creation. So for that, we need to start the main managing daemon, which will be spawning processes. It's called LNP daemon. It will build soon. Here we see the nodes connected, talking to each other constantly. It does nothing for now until we issue a command for it to create a channel. And this actual command is issued with LNP clear. Again, what we do is we tell it to create channel and specify the information with which peer we would like to establish the channel. Yeah, while building, I will show you how the TCP communication happens. So we have 2 ports. It's actually 2 connection daemons talking to each other. And we see how they exchange the data. In this case, it's a ping requests. 12, number 12 demonstrates this is a ping command. And there is a Pong response on that being comment, which is number 13. So we can look into the traffic, we can turn the encryption off and analyze how the all communications between parts of the daemon are happening. So here we have the LNP click saying to create a channel. It connects to these message buses. All of them are dumped here. It says it issues the required ones. And what we will see here in LNP daemon is that it basically, oh, I haven't built the execute binary file, but it receives the command and it acts basing on that command. So if we will look into here, we will have, again, 3 connections daemons. We will have LNP daemon here running, and if we will run gossip daemon and routing daemon here, we will have the whole node operating and build a channel daemon as well. So, yeah, something wrong with the binary file, but anyway, that's the way it works. So on the next call, I will be showcasing how the channel is actually created and how you can put in RGB assets and do the transfer of the assets. So I think that's the main part, which I would like, which I was going to demonstrate you. So what I would like to ask is basically anybody who is interested in developing Lightning Network further, we really need more hands for creating different parts of the LNP node, completing the whole Lightning implementation. The point is that basically we had to start with the basics, because originally we were planning to use Fast Lightning library by Square Crypto and Matt Corallo, but unfortunately, again, it's very monolithical, and we were not able to embed the functionality that we need and split it into the components the way we need without rewriting most of the library itself. And the overall time that it takes to propose a PR and it get it accepted to Rust Lightning is, like, we have a PR that is there for 9 months. So we decided finally to re-implement the functionality of the Lightning node from scratch, which is mostly done in terms of code, but haven't been completed in terms of the integration of different code components. And this integration can be done in this event driving modular way. So you don't need anymore to be very experienced Rust developer, because the code that you need to write is really simple. And I hope this LNP node will become a tool for experimentation of developing Lightning Network functionality further. We start with RGB, of course, and the RGB part will be completed by me and the colleagues who are working together with me in the next week. The core of RGB part. Of course, there will be much more development, and especially in terms of adding some decentralized exchange functionality, because this Lightning node will be the node that will be not just able to run Lightning channel, but also exchange information about different rates, fees, create an order book, and all of that will be done again with the separate modules and services running extra channels. And with that, we will be able to integrate discrete log contracts and other interesting functionality that will make a real use of RGB assets and RGB smart contracts. Sorry for being very anxious today, because I spent the past weeks writing all of that and preparing and being a bit tired, but hope that you understood what I was trying to explain, and I'm open for any questions. Are you still here?
Yes, we're here. Thank you, Maxim.
Okay. Because for a moment I was was terrified that the connection broken.
No. You were online all the time. Great job.
So guys, if you have any questions, if you need some information to be talked over again, speak up. You have time. Maybe you want to see some slides more in more details or some issues to be explained. Don't be shy.
Unfortunately, I hadn't time to prepare the proper presentation, so it was more like ad hoc. But after the release of the completion of RGB functionality, I think we will do a proper demo with and proper documentation explaining how to use the node, how to do all the asset issues, and so on.
What do you think are like the after this first demo experiment? What do you think are the critical parts in using in production some level of Lightning RGB right now? Basically, did anything emerge of unexpected about difficulties or showstoppers or possible critical points, except for the Rust Lightning implementation shortcomings?
Well, fortunately, we haven't met any showstoppers. The first part in the whole story was the completion of the overall protocol stack and this message bus architecture and everything around that, because it encompasses a lot of complexity. After that, for now, we have the whole skeleton of the system ready to go. Like it's ready for production purposes. It's very robust. The only thing that we need to add to the system in order to use it in the real world is to add specific components of functionality. So all these parts that were made for Lightning Network over the last year, like multipath payments and many other enhancements, they have to be implemented. The case is that they can be implemented really fast. So with this architecture, it takes me like about 2 to 3 hours to implement a couple of Lightning Network messages, like opening channel or doing some procedure, like doing some workflow scenario from Lightning Network. Implementing it takes just a few hours, because basically what you need is to copy from the specification the structure of the message and say which action take after this specific message and where to forward it. And that's all. So what we need is to complete the whole functionality of the Lightning Network. And that's why we would like to invite more contributors, because of course we can do it ourselves, but it will take more time. But again, the whole Lightning implementation, I mean, not RGB part, which we'll be completing towards the next week, but the rest of the Lightning Network functionality and non-cooperative closings and all these edge cases will take more weeks to finalize, and that's where we need help. But other than that, well, there were no major showstoppers here. And I think that we will be going now with a quite frequent release cycle of the updated versions, adding functionality piece by piece for next few months until the whole RGB and LNP node will be completed. But of course, they can be start using in some environments before that, because, for instance, you don't need multipath payments to go live, or you don't need some edge cases of non-cooperative closings potentially before going live.
Thank you. Great.
Maxim,
Yeah.
you have We have two repositories. One is Rust LNPBP, where in the README file we also have the environment and dependencies information. And we have the LNP Node one. If I want to start contributing to the LNP Node, should I start from the Rust LNPBP as a repo with information, or I can just dive deeper into the LNP Node one?
Yeah, well, LNPBP, Rust LNPBP is LNPBP core library, which is quite complex thing. So of course, everybody is welcome to contribute to it, but it does all the bottom level work, and it's mostly completed. So we have to add few gossip messages there. Raj is working on finalization of noise protocol from Lightning Network encryption protocol. And these are the only two parts we need to finalize there. And well, we will have a version 0.2 next week, and it will be kind of release candidate or beta for testing purposes, but no more business logic to add. In future, we will be continuing adding such things as new, as what? Well, a Storm protocol or something related to the centralized exchange functionality or Bifrost specific type of messages, but again, it will be a more development. So in terms of LNPBP core library, it is mostly done for now. Where we need to put the development force is actually LNP Node. And those who are willing to contribute, they do not need to change anything in the LNPBP library. Of course, they need to read the documentation, and we will be happy to answer the questions which parts of LNPBP core library can be used to implement that or that part of the node itself. But writing the code for the node will be much simpler than doing anything for the core library. Also, such things as additional RGB schema for non-fungible assets, for instance, they are done all at the level of RGB node. So it's similar with LNP node. The business logic level of functionality that doesn't touch the core technology protocols and standards, it's all residing in the nodes themselves. And the standards and the LNPBP core library is written in a way that once it's finalized, there is not a lot that can be added to it other than new protocols and standards. Sorry, Olga, I interrupted you. Go.
No worries. Okay, if I have some piece of hardware that I want to use as for an LNP node, for example, and I want to build the LNP node on that piece of hardware, whether it's Raspberry Pi or whatever, is it too soon to start digging into what we have? And if yes, after which milestone that we need to achieve that can be possible?
If you have hardware, sorry, I haven't heard.
Yes. If I want to run a node, an LNP node on a piece of hardware.
Well, for LNP node, we clearly need to get to the release point next week. So today it's too early. It's more like preview and start understanding the node internals and for developers to maybe try to contribute something. But from the next release, which I hope, if nothing will prevent it, will happen the next week, you will be able to start compiling and setting up LNode on your own hardware or devices and integrate into wallets. So the integrational work can start from the next week or next week after the next one, because I would like to take a bit of rest after all of this finalizing. And the actual commercial use to issue tokens and play with them, I think it will take several weeks more to test everything and make sure that it sticks together. So Of course, we don't have a lot of capacity to create a support, because always when community starts playing with some new technology, there will be plenty of questions. So there will be plenty of questions about LNP Node. There will be plenty of questions about integrating RGB and questions about RGB with LNP Node. So we will just, I just like to say that we have very limited capacity, which is mostly directed for the development and completion of this product. So in this case, it could be a bit delays in that. And of course, we will spend the resources for the project that we're supporting the RGB and actually providing the financials for the development. So the Bitfinex and related companies will have a priority in terms of helping them to integrate and do something. So realistically, I think the time for a broad public will be closer to the new year, when we will run through these internal integrations, and we will try and test these nodes with the software at Bitfinex and with those developers who already work on the integration. And starting from the next year, it will be the best time for bringing RGB and LNP Node into other wallets or other systems that's out there.
Gotcha, thank you. Any more questions, guys?
No, thank you.
Okay, then. If you have any questions, you know where to find us in any case. Now I can probably offer either to switch to other topics on the agenda or to finish the call if everyone's tired.
Well, we have a number of topics, especially regarding the partially signed Bitcoin transactions and using them with the hardware wallets regarding the security of the tweaks. But frankly speaking, I'm a bit exhausted, so I would prefer to postpone it on not on the next week, but on the week after the next one, after we will finish the demo of the second part of the demo.
Makes sense for me. I think there is more priority on finishing the second part of the demo, and nothing in contrary with postponing of 2 weeks.
That makes sense to me also, and today we had a lot of information of what needs to sink in a bit.
Sounds good.
So we can wrap this up.
Thank you, everybody, for joining us and participating in the call.
Thanks, Maxim.
Thank you, guys. All the information will be posted offline. I'll send the links. Bye-bye.
Bye.
Bye-bye.
Bye. Thank you.
Bye-bye.
Bye.